Okay, welcome back to Intro to Database. I say welcome back because we've basically finished the first part of this course, which focused, as you know, on Access, the database system that we used the first 7-8 weeks to look at good databases, to do some things in Access like queries, forms, reports. Did a lot with tables. So we know what a database looks like, a relational database. But now we're kind of taking a step back. And by that, I mean we're going to start from scratch, where we don't have a database. We're going to design a database and talk about the principles that govern designing a good relational database. So we start in Chapter 4 of the hands-on database book, the second book that you have for this class. And of course it's entitled Database Design. This design section of this course will last the next 4 weeks, and we'll cover chapters 4, 5, and 6 out of the hands-on database textbook. Okay, so let's move along here. And it starts with logical design. We break it into two parts, logical design and physical design. Well, logical design is when you're designing the database from scratch. You have nothing. You may not even have a relational database management system chosen yet. The software that you're going to implement this in. So this is called logical design. As this slide says, we're going to focus a lot on entity design. An entity, as you'll find out, it's something that you want to keep track of. It's something that you want to keep information about. Well, we kind of know what entities are already. They become tables when you really build your database. An entity becomes a table. But in the logical design stage of this process, you use the word entity because a table doesn't exist yet, right? A table is the object in the database management system. Okay. At this point in the stage of coming up with a database, it says we don't really consider the limitations or features of the DBMS in which we're going to implement this database that we're going to design. That's true. In logical design, you should just design it for maximum usability, efficiency, and all that. But in the real world, typically businesses know which DBMS they're going to implement their database in. Just wanted to let you know that. Chapter 6, when we get there, talks about physical design, and like I said, that's when you take your logical design and you implement it and create the database. That's called physical design stage. You may have to change your design slightly to fit the DBMS, take advantage of some of the features and whatnot, but usually, like I said, you know the DBMS, so you've kind of designed it to fit the DBMS that you're going to have. Okay, let's get to the main part of this chapter. Is a diagram called ERDs, or Entity Relationship Diagrams. It says they're a common way of diagramming entities, and when you diagram entities and their relationships, you're basically designing a database, a relational database. The attributes are really just the fields that are in the tables or in the entities. So at this point, attribute and field mean the same thing, but in the logical design stage, we'll refer to it as entity and attributes. There is a chart coming up in the slide set showing you the terminology similarities between logical and physical design. On the diagram, the entity is simply represented by a rectangle. It has 3 parts: the name of the entity, the primary key, and then the attributes. And here's an example on the next slide. This is slide 5 for chapter 4. You can see it's a rectangle. The entity name goes at the top. You have your primary key field here. Not the word primary key, but the name, the primary key attribute or field. Then all the other fields are attributes in this particular entity. This PK notation, that's optional. This particular diagram was built with a product called Visio. So Visio puts a PK there to represent that it is the primary key. They also go one step further here and say that the attributes that are shown in bold are required. That means when data actually is going to get entered into this entity or table here, those are the fields in bold that are required, meaning you have to fill in a value for those fields before the system will allow you to continue. Okay, so that's an entity in an ERD. Once you have your entities figured out, basically you've figured out which things you're going to keep information about, you know, like a customer or a student or an order, employee, items in your company, things like that. Those are really entities. Once you have your entities, there's relationships between entities. We've seen that when we worked with Access. We had multiple tables in our database, and they have relationships between the two. So the relationship between the entities, we kind of know how this works. We've seen it already, but you repeat one field. It says the primary key. Usually the primary key, it's almost always the primary key. From one table into another as the foreign key. Okay, so we've seen that that becomes a one-to-many relationship. The primary key table, sometimes you hear terminology, it's called the parent table. And then the related table, the one with the foreign key, is the child table. That's usually on the many side of the relationship, or that is on the many side of the relationship. It says there are different ways to depict these relationships depending on which notation you use on your ERD. One way is this arrow-headed relationship. It's just simply a line with an arrow pointing to the parent side of the relationship. So this is a one-to-many relationship. This says a building can have many rooms. Each room relates back to one building. So that's the arrow relationship. We won't use this notation, but you might see it in a different textbook or a different product that you might use to create ERDs. We've actually seen a different notation in Access. Access had a line representing the relationships, remember, in the relationship window. Then on the many side, it had that infinity symbol. Okay, so that was what Access uses. What we're going to use is here on the next slide, slide 8 here, crow's feet notation for relationships. As you can see, it's still a line representing the relationship between the two entities. But now we have a different kind of notation on each side. This one is also representing a one-to-many relationship. This says a building can have many rooms. The many in the crow's feet notation looks like this little triangle, you know, with 3 prongs on it. That's the many symbol. Each room relates back to one building. Okay, so that's the symbol for a 1. It's just that line right through there. But you also notice there's 2 other notations. This is something called the minimum cardinality. And I'll talk about that in a later video that comes up later in the chapter. But this is also a one-to-many relationship with the crow's feet notation between 2 entities. So it says here, the crow's feet notation is just one alternative of many that are used. We saw the arrow, what that looks like. We saw in Access how they do it. And there's other types of notations too that are not really covered here. But the crow's feet notation is a pretty popular and common type of notation. And that's why we like to use it in this class. It says it's a bit more complex because there's more information about the relationship. What they're talking about there is that minimum cardinality that I'll talk about later. Alright, this is the end of the first video for this chapter.